As in English, I have some good news and some bad news for Algebra 1. The good news is this is the last class period of new instruction. Now tomorrow we will still have some video teaching on the test review, so make sure you get that squeezed in. But we have no new information that we're going to be learning in video lessons for almost the rest of this week in Algebra 1. That's the good news. The bad news is that means it's test time. And so we're steadily working our way toward that. For today though, it's our last piece of new video instruction in this chapter for the week. We will have one new one in a new chapter on Thursday, but this is the last one for this chapter. And what we're going to be doing in it is factoring completely. Now our whole chapter has been on factoring. I think it's been pretty fun. I hope you guys have enjoyed it. I've had some positive feedback from it. It seems like things have gone pretty well. And something that we've learned in factoring is that the first thing you want to ask yourself is if there's anything common that you can pull out of all the terms that are involved before you start breaking it down into commonly what are binomials. And so we're going to factor completely numbers 1 through 5. And I will tell you up front, the number 1 is going to be slightly challenging, but I know you guys will do really well with it. Hopefully we can build some confidence. If it is, you feel like really tough, don't get too discouraged for what all the rest of them are going to be, because I actually think it gets easier and much easier on 3, 4, and 5 as we move on. And really, I do believe it's probably numbers 1 and 2, and certainly 1 that may be the most difficult of all of these. So stay with me and keep your enthusiasm high during and after number 1. Everything's going to be just fine. So on 1, the first thing we need to ask ourselves is there anything common between these two binomials? Is there anything common? First of all, in the numbers that are used. And yeah, we notice right off the bat, there's a 5 and there's a 5. And so we can factor out a 5, pulling them out by division. Okay, and the way that we'll write them is that they're being multiplied together, so the way to get them out into this form is to have to divide. But before we do that, we also need to look at our variables and see if we have any commonalities that are found there. How about in this one, the a? That's a to the first power. Is there an a in the second term? Yeah, there's an a, and it's also to the first power. And so I want to use the greatest exponent that's in common between the two, and since they're identical, well, that makes it easy, and there's really not much of a decision to make. I have an x here. Do I have an x over here? Yeah. So I can pull out x, but I need to ask about my exponents. This x is to the 5th power. This x is only to the 1st power. What's the greatest power they have in common? And that is a 1, because you can't go any higher than 1 for this one, so I just leave it at 5ax. Now, I've been doing this some anyway on this board. I'm not drawing a line here and putting 5ax under it as a division symbol. I don't want you to think that I'm discouraging you from doing that. In fact, if you feel like you need that, I by all means would encourage you to do that. I'm just not as much like we did in the classroom at school, and the reason for that is, you can tell, here's some proportion of the size of my hand. Okay, this is an extremely small board. And so I have to work within the confines of the space I have, and where I can, I have to save a step or two that I'm writing out, but I'm still going to be speaking those steps. So what we're going to do is divide, and on your paper, please, if you'd like to do it, write it that way. Divided by the fraction line and 5ax underneath. So we're dividing by, or pulling out a 5ax from each one of these two terms. Okay, divide 5 by 5, what I have? 1. But because I'm either going to have a variable or variables that will come after, I don't write that 1 because it's understood. So 5 divided by 5 is 1. What's a to the 1st power divided by a to the 1st power? When I divide variables with exponents, I actually end up subtracting those numbers. And so a1 minus a, that is the exponent 1. The exponent's 1 minus 1 gives me a, keep the base, the variable itself, gives me a to the 0 power. Any number or any letter to the 0 power is 1. However, I don't write that when I have other terms that are coming, or other parts of the term coming after, because that's understood. Okay, I have x to the 5th divided by x to the 1st. I actually subtract those exponents. I'm still going to have an x, which is my first expression that's going to be left in pulling out a 5ax. X to what power? The exponents, 5 minus that 1 exponent that's found on that x in the factoring, is going to make it x to the 4th power. Okay. And now I can either ask myself what's negative 5 divided by 5, or if I prefer, I can just put the sign and forget about negatives and just say, what's 5 divided by 5? Well, once again, that's 1. If I have a variable or variables that'll come after that, I don't write that because it's understood. A1 divided by A1, 1 minus 1, a to the 0 power. That's 1. I don't write that one either. X, okay, divided into, x1 divided into x also to the 1st power. What is 1 minus 1 in exponents? 0, x to the 0 power. That's pretty cool, isn't it? We don't normally see that, but I have 1, 1, 1, not 111, but 1 times 1 times 1, which is still basically meaningless from where I started, so I'm not writing any of these. So the last one, though, with which I can do nothing, is y to the 4th power. Close parentheses. So I have 5ax, open parentheses, x to the 4th power minus y to the 4th power. Guys, before we go any further, I ask you to pull out your notes on the difference of a square, as well as the 2 potential formulas for the perfect squares. When you have a middle term, and it can either be a positive middle term or it can be a subtracted or a negative middle term, okay? And that's going to tell you something about the square, whether it's positive or negative, that second number. But when you have the difference of the square, the way you do that is by a conjugate. Okay, you're going to have 2 separate parentheses because this is not a perfect square, even though it might look like it. But you're going to do it by the conjugate, where you're going to have the square root of this term plus the square root of this term in one parentheses. And in the second parentheses, you're going to have the square root of this term minus the square root of this term. And I think we discussed that. I know we did have it in pre-algebra, and sometimes between the 2 classes it gets jumbled. But in taking the square root of a variable with an exponent, all that you do is you divide the exponent itself by 2. And here's the math behind that. When you have a number, when you have a variable with an exponent and you square it, remember how you take that exponent and you multiply it by 2? Okay? Well, a square root is the inverse or the opposite of that procedure, in which you divide the exponent by 2. And if you can evenly do so, then these are both squares that you can break down into that formula that we've been using in this chapter. So make sure you have the difference of a square formula before you. And as you do, I'm going to rewrite 5ax, open parentheses, what's the square root of x to the 4th power? That means 4 at the exponent, 4 divided by 2. Now that's not true of numbers, but that's true of exponents. That's how you do it. 4 divided by 2 is x to the 2nd power, or x squared. And I say plus, this is the formula, look at your rules, I'm not going to rewrite them today, you have them in your notes. But the formula for a difference of a square is the square root of the first number plus the square root of the second number. What is y to the 4th power? If you take the square root of it, you divide that power itself, keep the base, but you divide the power by 2. 4 divided by 2 is y squared. But that is just one side of the conjugate. The other is the same 2 terms, x squared and y squared, but this time there's a subtraction. And so you see that conjugate rule, the difference of a square is the square root of the first term plus the square root of the second term in one parentheses, and then multiplied to the second term, and you have the square root of the first term again, but this time it's minus the square root of the second term. Okay? Now, from that point, am I done? Sorry to say, guys, but I'm not. And here's why. I keep 5ax, okay? 5ax. I keep x squared plus y squared, and the reason for that is it cannot be broken down any further. You cannot break down the addition of two squares with no middle term, but you can break down the difference or the subtraction of two perfect squares even further. So this one and this one I keep. I factor this one even further. How? By the same rule I just used. By the difference of a square. How do I do that? And this is all going to be multiplied together. It's like this should all be on one continuous line, but because of space, understood as multiplied, I'm just writing this part, broken down further, factored more below. How do I do that? I take the square root of the first term and the square root of the second term. What is x squared if I take the square root of it? Remember, I divide the exponent itself, keep the base, divide the exponent by 2. 2 divided by 2 is 1, so it's just x to the first power. Plus the square root of the second term, y squared. And if I divide the exponent, keep the base, if I divide 2 by 2, I have just y to the first power. But remember, look at your rule and your formula. The difference of a square is the conjugate, meaning x plus y, but also times x minus y. And guys, that is the fullness of the answer, factoring completely 5a x to the fifth minus 5a x y to the fourth. It's this big long answer right here and all these steps through which we went. And all it is initially pulling out commonality, and then it's using the shortcut formula for the difference of a square twice. Don't get discouraged by this one if you think, what? And I can almost hear and see, I'm never going to get this. No, you are, and I know several of you already have it, but don't worry, this is one of the hardest ones we're going to do. I'm telling you, it gets easier from here. And so let's move on to number 2, and let's make sure we have our wings underneath us and we're flapping and we're really starting to fly all by ourselves. Okay, so let's do this one. X to the fourth minus 9x squared plus 8. If you'll notice, there's nothing in common that I can pull out, and I think that's why this one's easier, truthfully. There's nothing in common that I can pull out of here. And so what I need to do is ask myself, there's no coefficient that's greater than 1 in front of that x, the first term. And so I can just look at this one right here and ask myself, what are two factors of positive 8 that when added together give me negative 9? Well, those two factors are obviously negative 1 and negative 8. Because negative 1 times negative 8 is a positive 8. But when you add negative 1 to negative 8, you end up with negative 9. And so that's exactly what I need to break this down further. And the way I do that, guys, remember this is a pretty simple one, and that all I'm going to do is just have 2 parentheses. And what I do is take the square root of my first term. It's not just going to be x, okay? But the square root of my first term, which the square root of x to the fourth means I divide that power of 4 by 2. And that's going to give me x squared to start both of these parentheses. And so it's exactly like our x squared plus x number and then plus just a number. The only difference is we're 2 powers up on the first one and we're 2 powers up on the middle one. That's the only difference between the two. And so don't get confused by it. X squared here, x squared there. And what two numbers now, and numbers only, there will be no variables attached just like our other ones we've done. What two numbers do I fill in for here and here? The two factors of positive 8 that when added together give you negative 9. And those two factors are negative 8, we said, and negative 1. That's pretty cool, isn't it? So x squared minus 8 times x squared minus 1. And we have factored it. However, guys, we have not factored it completely. And here's why. Because of the rule, of the difference of a square. Now, x squared minus 8, is 8 a perfect square? No, it's not. So we can't do anything with that one. And so x squared minus 8 is going to remain. You cannot factor it any further. But what about this one? X squared minus 1. X squared minus 1. X squared, that's a perfect square. Our issue was 8 is not. Guys, 1 is a perfect square. It's not one you can really do a whole lot with it, but it is a perfect square. And you have two numbers that are squares of themselves, and so you can use the rule. Look at your sheet that you have these formulas written down. You can use the rule, the shortcut of the difference of a square by using its conjugate to break it down. And what that is you take the square root of the first term, x squared, and to do that you divide the exponent 2 by the number 2, okay, which gives you x to the first power. And so you're going to have that in 1, and you're going to have x to the first power in the second one, and then you just take the square root of the second term. What's the square root of 1? Well, man, that's easy as all get out. It's 1. It's 1. And because it's the difference of a square, your formula, okay, says the system dictates 1 has to be a positive and 1 has to be a negative. Which makes a lot of sense because your standalone numbers, negative 1, what are two factors of negative 1 that when added together give you no middle term or 0? That's negative 1, positive 1. 1 minus 1 is 0. And that's the math sense behind it. But use that shortcut to break it down. So factoring this is x squared minus 8, one binomial, multiplied by a second binomial, x plus 1, multiplied by a third binomial, x minus 1. And again, I think these will be some of the most complicated of these that we'll do. I believe the other ones are simpler. Whenever you have 4 terms, but if you'll look, there's nothing in common that you can factor out of all 4 of them. When you have 4 terms, kind of like some of these factors that we have done, guys, what you can do is throw parentheses around 2 of the terms. Okay? Make 2 sets of binomials. And then see what commonality there is that you can factor out of them. That's not too bad, is it? 2xy minus 7x. Okay. Do I have any whole numbers in common I can pull out of there? No, 2 and 7 don't coincide well together. So I can't do that. They're both prime numbers. How about x? Yeah, well I have an x here and I have an x there. And so I can pull an x out of this first set of binomials. How about a y? No, there's a y here, but there's not a y in the second term. So all I can take out is an x, which means I'm going to divide both of these terms by x to the first power. What is 2xy divided by x? Well, I'm just going to keep my 2. X to the first divided by x to the first is x to the 0, which is going to be nothing expressed, even though technically it's 1. And I just bring down my y. Minus, what's 7x divided by x? Well, I keep my 7. And I just drop my x. Okay, plus my second parentheses here, is there anything common between 10y and negative 35? Not variable-wise, but numerically, yes, there is. And that number is 5, which will evenly go into each one. Okay, so let's pull a 5 out of 10y. What's 10y divided by 5? 10 divided by 5 is dos. I can do nothing with the y. What's negative 35, or if I want, I can just write the minus sign and forget about negatives and just say, what's 35 divided by 5? 35 divided by 5 is 7. Whoa, wait a minute, look at this. That's pretty cool, isn't it? I have the same thing in parentheses right over here. And so when that's the case, I just use one of the commonality in the parentheses that's being added to that second set. I just use one of the 2y minus 7s, and I combine what's found outside of the parentheses into the second parentheses, but I drop the addition sign, and that's why they are still true, and they're multiplied by each other. And so the answer to this 4-term polynomial is 2y minus 7 times x plus 5, each one of those being in parentheses. See, I think that one's easier than the two that we did here. And these next two, they're similar, especially 4. Let's do that. We have a 4-term polynomial. They have nothing in common as far as in every one of the terms having a common variable. We don't have that. But what we can do is just throw parentheses, okay? We can just throw parentheses and understood they're going to be added together whenever we do that. Otherwise you multiply them, that's a whole different ballgame. But understood they're being added together when you put those parentheses around each. And then factor out what's in common. AM minus AN. Here's an A. There's an A. And they're both to the first power, so I'm going to factor out an A. Okay? How about an M? Nope. How about an N? Nope. So all I can bring out of that first parentheses is an A. What is AM? What is the morning? Divided by just half of the morning. A. AM divided by A is simply M. Keep the sign, minus in the middle. AN divided by A. I drop the A and it just becomes an N. Okay, and don't forget the plus right here. That's important. I have negative PM, evening, plus PM, a practicing nurse. What do I have in common between the two of those? P and a P. M? Nope. N? Nope. So only a P. But remember the rule, if the leading one is a negative, I want to make sure that I pull that negative out of there. So it's not just P, but it's a negative P that I'm going to factor out. Okay? And so what is negative PM divided by negative P? Well, the two negative P's cancel each other out, and I'm left only with an M. Okay? What is PN divided by negative P? PN divided by negative P. Well, P divided by a negative P is a negative 1. But I'm not going to write the 1 because I have a variable that comes after, and that's understood. And all with which I'm left is an N. Close parentheses. Look at that, guys. Same thing in one parentheses as I have in another. So to write this in complete factored form, I keep one of the two that's found in parentheses that are simply being added together. And the reason for that is I'm going to end up multiplying instead something to it, and that to which I multiplied is what's found on the outside of the parentheses. And I put them inside the second parentheses, which is A plus negative P. Of course, we understand the negative overrides the positive, and so in simplified form we just write it as minus. M minus N times A minus P, each one of those binomials respectively being in its own parentheses. Does that make sense? Not too bad, is it? Number 5, okay, this one's a little bit more to it. It's a combination of what we've been doing here, but I still am not sure that it's as difficult as maybe the first one that we did. I have 4 terms, no commonality in all 4 of those, and so I'm going to slap parentheses. Oh, sorry about that. Cut that off a little bit, didn't I? I'm going to slap parentheses around each one of these binomials. Okay, and that was squared, and let me write it in blue so it doesn't look all funny. Sorry about that. Again, close quarters, I'm working here. So I'm going to put the parentheses around here, and then I'm going to put the parentheses around here. But understood that they're being added whenever I do the parentheses to each, and not all multiply because they're all being added and subtracted to start with from each other. Okay, so I have the parentheses around each being added together. What do I have in common between a 2 and a 5? Nothing. They're both prime numbers, so we can't pull anything out number-wise. How about variable-wise? A y. Good. Oh, a y. And I want to do that y to the greatest exponent possible that they have in common. That one's to the third. That one's only to the second. So the greatest I can use in common is only to the second. y to the second. Okay, my numbers themselves are going to stay the same, 2, but what is y to the third divided by y squared? Subtract the exponents. 3 minus 2 is y to the first, or as we would say it and write it, just y. Okay, I keep my number as well as my sign, plus 5. What is y squared divided by y squared? That's y to the 0 power. 2 minus 2 is y to 0 to the 0 power, and that's just 1, and we don't write that because it doesn't change our number any. Plus, all right, what do I have in common between negative 8y and negative 20? Number-wise, the greatest number, I know 2 works, but I also know a greater number than that works, and that's 4. But because the leading number is a negative, I'm going to pull out a negative 4 to turn it into a positive. It's just the way you do factoring. It's one of the rules involved. And negative 8y divided by negative 4, negative 8 divided by negative 4 is a positive 2. I can do nothing with the y, and so I leave that. What is negative 20 divided by negative 4? That is a positive 5. Bingo! Does that look familiar? 2y plus 5, 2y plus 5. That tells me that I'm on the right track. And so what I'm going to do is only use one of those, since those are being added together, 2y plus 5, and I put in parentheses what's left over outside the parentheses, but now being multiplied, and that's the way that combination works, times 2y minus 4. Boom. So I'm done, right? Oh, wait a minute. I'm told to factor completely. That one's done, but look what we have here. Y squared, is that a number that you can, or a term I should say, that you can take the square root of it? Yes, because 2 can evenly as an exponent be divided by 2. Is 4 a number that you can evenly take the square root of it? Yes, it is. Guys, what we have here is the difference of a square. And the rule of a difference of a square is you use the conjugate of its multiples, meaning you take the square root of each term and you put in one parentheses plus, and the same thing in the other parentheses, but minus, just like we've been doing back here. And so I'm going to keep my 2y plus 5, I can't factor it any further, but y squared minus 4, what's the square root of y squared? I divide the exponent by 2. 2 divided by 2 is just 1, so y to the first power, I just say it as y. And then I'm going to have plus the conjugates, okay? And the first one, that's going to be plus, what's the square root of 4? That's easy, that's 2, because 2 times 2 gets me to 4. So I'm going to have y plus 2, but remember, for the difference of a square, you have to do binomials that are conjugates of each other multiplied, which means you have 2 sets of parentheses with binomials that are the same, except the second one is the opposite sign in the middle. So I'm done with 2y plus 5 times y plus 2 times y minus 2. And if we had the time, we'd FOIL all that out, and this one, and this one, and this one, and this one, and check them and show how we're correct. But we don't have the time to do it. We've done enough of that anyway, you guys understand. Remember, if you need to, these are recorded. So you can go back and you can go through these again. If you don't get it really well the first time, guys, take advantage of this opportunity, and with the additional time you don't have traveling to school and sitting around at school, and if you need to and you want to do well, you don't have to, but if you want to, take some extra time and look at maybe number 1 the second time in the video if you struggle with it, or number 5, because every one of you guys can absolutely nail this test, and I expect you to do that. Okay. That's all for today, and I will see you tomorrow on video for our test review.